In the last video, we looked at how to solve a fifth degree polynomial equation. We looked at two examples. They had real roots, and some of them were repeated, as many as 3 times. Now, if you're given this equation here, you're asked to solve it for real solutions. That you wouldn't have to do much work because it doesn't have any real solutions. That's all you have to say. And the reason is, if you look at the terms, you got x to the 6, 14x to the 4th, 49x squared plus 36. The coefficients are all positive. The exponents on the variable are all even. So whatever number you put in there for x, you're never going to get a negative. You can get 0 if x is 0, but if you place x by 0, everything cancels out except the 36. 36 does not equal to 0. So 0 is not a solution. So this one has no real solutions. And that's why it says find the non-real roots of the following 6th degree polynomial equation. So we're still going to use the synthetic division procedure that I did on the last 2 examples. So normally if the coefficient of the lead term is 1, x to the 6th has a coefficient understood to be 1. We look at factors of 36. So if we expected rational real solutions, we would use plus or minus 1, plus or minus 2, plus or minus 3, and so on, until we got this broken down to something we could work with. Let's say quadratic we could factor or something like that. So what I'm going to do here, I'm going to start off with the smallest factors of 36. So I'm going to try 1. I would try, in ordinary, I try plus or minus 1, but I know it doesn't have any real solutions. So I have to try an imaginary number, so we're going to try I. Okay, so again, keep in mind, as I said last time, that you have to have the polynomial, in this case the left side here, that's the polynomial, in descending powers. And if there's any missing terms, you have to fill those entries with 0. So you have x to the 6th, and then the next term should be x to the 5th. We don't have it, so this should be a 0 here. And then we have an x to the 4th. Coefficient is 14, then we should have an x to the 3rd. Don't have it, so the entry there is 0. And then we should have an x squared. Coefficient is 49, no problem, we put it down. Then we should have an x term, don't have it, so the coefficient is 0. And then the constant term is 36, and now we continue. So we're going to try I, and then again, this is kind of like a trial and error. So we bring this down, and then we multiply by I. I times 1 is I. So we bring it over to the next column. 0 and I is I. Okay, and then I times I is I squared. That's a negative 1. So I put a negative 1 there. 14 and negative 1 is 13. And then we go to the next one. I times 13 is 13i. 0 and 13i is 13i. And then we multiply by I over here. I times 13i. That'll give me 13i squared. But again, by definition, I squared is negative 1. So this becomes in a negative 13. 49 add negative 13 is a 36. And then we continue. I times 36 is 36i. That comes over to the next column. 0 and 36i is 36i. And then we continue. I times 36i is 36i squared. That gives you a negative 36. So 36 and a negative 36 is 0. So because I got an entry of 0 for the last number here in this row, that tells me that I is a solution of this equation. It also tells me that x minus I is a factor of this polynomial. Okay. Now, because it works, we could try it again and see if this repeats, but it doesn't. So just to save some time, I went ahead and tried negative I. So bring this down. This is 1. Negative I times 1 is negative I. Add I and negative I, that's 0. And then negative I times 0 is 0. Got 0 over here. 13 and 0 is 13. Okay, and then negative I times 13 is a minus 13I. Then minus 13I, or 13I and a negative 13I is 0. This gives me 0 here. The negative I times 0 is 0 to the next column. And then 36 and 0 is 36. Then negative I times 36 is minus 36I. 36I and a negative 36I gives me 0. So far I know that I, the imaginary number I is a solution, and also negative I is a solution of that equation. Okay, remember we expect 6. We have 2 right there. Now I could continue with this method, and I would try, say, next I would try maybe a 2, and then a negative 2I, maybe 3. I should say I would try 2I, and then negative 2I, or 3I, and then negative 3I. But if I look at this, remember when I do my first division here, and that's what we're doing here. When I put an I here, this synthetic division, we're actually dividing this by x minus I, and it does go 0 times. And this is minus I, we're dividing by x plus I. There's your remainder. Okay, so this row right here, the 1, 0, 14, 0, and so on, that's the coefficients of the original polynomial. And then in the next row, 1, I, 13, 13I, and so forth. That's the coefficients of the next polynomial. It reduces them by 1, so this is a 5th degree polynomial or 6th degree polynomial. Then it's a 5th degree, and then we do a division again. This is 4th degree. So basically then what we have is these numbers in this last row are the coefficients of a 4th degree polynomial. So basically 1 then would be the coefficient of x to the 4th, and then this 0 for x to the 3rd here, and then 13 x squared, and 0 would be the coefficient of the x, and then we have the constant. Okay, so basically this is then, I can rewrite this as x to the 4th, and then it would be 0, x to the 3rd, so the next one then it would be a plus 13. Again, 4th power, 3rd power, and then 2nd power, so this should be an x squared. And it'd be 0x, and then 36, so this is plus 36. Okay, now we have a trinomial. Can we factor this? So you got x squared, so it's okay, the x to the 4th here can be broken down into x squared. So it's like it's a regular trinomial here. So instead of a quadratic, it's a 4th degree. And then now let's look for factors of 36. Factors of 36 would be 36 and 1, 9 and 4, 4 and 9. And what signs do we need here? Well, because of what we have here, it has to be a plus here and a plus this over here. So notice x squared times x squared is x to the 4th. 9 times 4 is 36. That checks. Multiply here and here. Okay, so this would be a 4x squared and a 9x squared. Add up, and that gives me a 13. Okay, so it does check out. So now, to complete the solution of this, we simply take these two factors. We want to know when are these factors equal to 0. Well, we say, well, x squared plus 4 is equal to 0. And we take x squared plus 9 is equal to 0. And then we just solve these. So isolate the x squared term in this case. So we just bring this 4 over, so x squared will equal to -4. And to solve for x, we take the square root of both sides. So basically this will be the square root of -4, so this is equal to, the square root of 4 is 2, and because the minus would stay under the radical, this would come out to a 2i. Okay, square root of -4 becomes 2i. The I comes because you have a negative under the radical. And because it's a square here, we take plus or minus the square root of both sides. Okay, do the same thing with the x squared plus 9. Solve for x squared. X squared would equal to 9. Take the square root of both sides, plus or minus, then x would equal 2 plus or minus. Root of 9 is 3. And of course the negative stays under the radical, so that of course generates the I. So the solutions of this 6-degree equation, and of course we expect 6, and they're all non-real or complex, so we could just list them again. Plus or minus I, plus or minus 2i, plus or minus 3i. So 6 solutions for this 6-degree polynomial equation, and they're all non-real. Thanks for watching. We'll see you next time.